follow these 3 easy steps and you'll have obliques like, what do you mean not those obliques? Oblique asymptotes? All right, mathletes, so let's jump in here and let's talk about these slant asymptotes, which are also known as oblique asymptotes, all right? And so what I'm gonna do here is I'm gonna use our friends over there at manhassetschools.org. And the reason I pulled them up is because they have a classic definition right here of slant asymptotes. And I don't know about you, right? But I know me, when I was in school, I would read a definition and I would end up more confused than when I started. So what I'm gonna do is I'm gonna teach you how to translate these definitions, right? So they make sense. And so don't overlook these definitions. Make sure that they make sense, or else you're gonna end up really lost, or you're just gonna end up trying to follow all these steps and you're gonna be more lost than ever, all right? So let's look at this. So instead of a horizontal asymptote that we looked at last time, right, a top-heavy rational function. So what we're gonna look at when we say top-heavy is we're gonna look at the degree. And remember, the degree is the largest exponent. So when the degree of the numerator, right, say the largest exponent you have in the numerator is 5. So let's say and ignore everything else. We're just gonna talk about the degree. So say the numerator has degree 5. And it's 1 more than the degree of the denominator. So if this is 1 more than, again, I'm gonna ignore everything else in the denominator and I'm just gonna focus on that degree, which is the largest exponent. So whenever we see this action, right, then this is gonna have a slant asymptote. And of course you could have some extra business going on here, right? You're gonna have some plus and you have some additional terms. But the main point is when you're looking at the degree, right? When everything's in descending order, you're looking at your leading terms. You look at the degree here, the largest exponent. This top one, the numerator, is going to be 1 greater than the denominator. That's when you have these oblique asymptotes, all right? These slant asymptotes. So make sure you got that down, all right? So when you look at the largest exponent in the numerator, it's going to be greater than the degree of the denominator by exactly 1. So that's how we know we're gonna get one of these slant asymptotes, all right? These oblique asymptotes, all right? So I just wanted to make sure you understand when these are gonna be formed, all right? So that's the most important thing. Now let's dive into, how do we actually find this line, right? How do I find the equation of this line? It's not too bad. Any questions so far? All right, follow me. All right, so now that we know what we're looking for, let's talk about how to get there. All right, so we're gonna have a rational expression, right? You're gonna have a polynomial divided by a polynomial, and the slant or the oblique asymptote, we said it occurs when the degree of the numerator is exactly 1 greater than the degree of the denominator, right? So again, we're just making sure we understand. We know what that means, right? We want to make sure that makes 100% sense. If it doesn't, then don't move on until you understand that. So that the numerator, boom, the degree is greater than the denominator by 1. If you forget, remember me, number 1. All right, so how do we do this? Well, what we're gonna do is we're either gonna use long division or synthetic division, right? Depending on the situation, to find our equation. And what we're gonna do is we're gonna grab the quotient after we do the division, and that quotient is gonna represent the line, the equation y equals mx plus b. I know here we have y equals ax plus b, but remember, we're just looking for the equation of the line, all right? So we're looking for something of the form y equals mx plus b, but m is just the slope, it's a variable, right? So here's a picture of what's gonna happen. You're gonna be given a function, a rational function, right? Look at the exponent here. The exponent for example 1 is 2. The degree upstairs is 2. The degree of our denominator is 1. So what you're gonna do, right, I'm gonna do it step by step, but I want you to see the big picture here. We're gonna do long division in this case, right? So and I'll walk you through long division just in case you forgot, and we'll have some videos linked for you to help you out. So we're gonna perform long division, and our quotient here, right? This quotient is going to represent the equation of that slant asymptote. So this is what we're interested in. And notice, you might get a remainder and you could ignore it. You don't need it, right? So, no, take it back. We don't need it. All right, so making sense? All right, so let's do one from start to finish. All right, so let's go here and let's find the slant asymptote. So first I'm gonna check my degree here is 2, my degree here is 1. We're all set. And notice we're just interested in this situation, we're just interested in that slant asymptote. So I'm not interested in any horizontal asymptotes or vertical asymptotes for this example. All right, so we're just focusing in this video on slant asymptotes. If you want to learn more about the other ones, check out the videos that I have linked below. All right, so we use long division, and just in case you forgot, remember we always divide. So I'm going to take my leading coefficient, that 2x squared, and I'm going to divide it by the leading coefficient of the denominator. And so we reduce this and we end up with 2x. So our 2x is going to go here, and I like to line things up. And remember what you're going to do with this 2x. You're going to go ahead and distribute, you're going to multiply it, right? So we're going to multiply. That's what comes next. That's why I put the M as a little reminder. So I'm going to distribute that 2x. And when I do that, I end up with 2x minus 2x squared, excuse me, minus 4x. All right, so we went ahead, we divided, we multiplied, and now we subtract. So what I like doing is I like going with a different colored pen and changing my signs so that I remember that I subtract. And when I go back in my notes, it's really easy to see exactly what I did. Or I could find my mistake easier as well, right? Because sometimes when you go back, you don't know what you did because everything's in the same color. All right, so use a different pen. That's a great pro tip for you. All right, so let's go ahead, combine our like terms, and we're gonna get 3x, and go ahead and drop down the minus 3. All right, last thing, we're gonna rinse, wash, and repeat. So we're gonna go ahead and take that 3x, and we're gonna repeat that process over again. So we're gonna take 3x, and we're gonna divide it by x. All right, the x's cancel. Don't you wish your x's could cancel? And then you're left with 3. So we're gonna put that 3 right here. And actually, we're free to stop. But again, just to get the practice, we're gonna distribute that 3, right? We're gonna multiply. We're gonna multiply, and we get 3 times x, and then we got the negative 6 right there. And then don't forget to change your signs. So I got minus, plus, so we're left with the remainder of 3. But again, we don't care what that remainder is. All we want is the equation of the line, right? We want y equals mx plus b, right? So this is our equation. Well, it's not equation yet, but that's gonna give us our equation of y equals 2x plus 3. So this is the equation of the slant asymptote. Is that making sense, friends? All right, let's do another example. Follow me. All right, so let's do this one right here. Notice this one's missing some terms, all right? So let's go ahead and let's add some placeholders, right? So again, make sure you understand how to do long division, because again, if one of these pieces is missing, this is gonna be much more challenging, right? And then you're gonna look like this guy. All right, so again, let's go ahead and put this in descending order. Boom. All right, so I got my placeholders. So notice there was no x squared term, so I put a 0 placeholder. There was no x term, so I put a 0 placeholder, right? So now we're gonna go ahead and divide like it's 1999. So first we divide our leading terms, x cubed divided by x squared, and we get x. So I'll put that x right there. I'm gonna distribute that x, right? So I'm gonna distribute, and I get x cubed plus 0x squared plus a negative 9x, right? And then I'm gonna go through and I'm gonna change the color, right? I'm gonna change the color so I know that I'm subtracting. So when we're subtracting, I just go through and change all the signs. I do it in a different color so I don't forget. So we go ahead, combine like terms. The beauty of this, right? Cancel, these cancel, and we're left with 9x. And then we're gonna drop down that 1. Boom, drop it like it's hot. And then now we're gonna go ahead and repeat that process. So we're gonna divide those leading terms, 9x divided by x squared, and you're gonna see something funny happening, right? And what I tell my students, right? This is what I tell my students, is that when you're dividing, look at what we're left with, right? Look what we're left with right here, 9x. This degree right here is 1. This degree here is 2, right? Once this degree is smaller than this degree, that's how you know to stop. So actually, this is our remainder. So this is our equation right here. So our equation is just y equals x. So our equation of this slant asymptote just happens to be y equals x. And I know that looks funny, but that's just the way it is. So if you were to graph this, right, we could use decimals or any of our graphing calculators. What you're gonna see is that as x or y goes off to infinity, positive infinity, we're gonna see that that function is gonna get really, really close to this line, y equals x. All right, folks. So again, as a summary, how do you find the slant asymptote? Well, first make sure that there exists, right? That one exists. And what you're checking for is the degree. Is the degree of the numerator greater than the degree of the denominator by exactly 1? If so, use either long division or synthetic division, and whatever you get as your quotient, that's gonna represent that equation of the line. All right, folks, I hope you're having a great day. Make sure you do a little bit of math every day, especially if you're in school, because again, what's gonna happen as you take a break, man, it gets really hard to get that motivation going again. So you wanna keep things up. All right, mathletes, I'm glad you stopped by. Don't forget to like, subscribe, tell a friend, or 10,000 about what we're doing here. Peace.